Great, thank you very much. Hi everyone. So I'm going to be talking about evaluating BGP roles as a way of showing what LLMs are capable of nowadays. Now you've probably seen how LLMs have improved a lot in the last few months, and we're at the point where you can take an off-the-shelf LLM that's just been trained on general internet content, and it turns out that it's very good at doing networking tasks. You can give it large chunks of work to do, you can leave it to progress on its own, you can come back sometime later and you find that it's done a very good job and saved you a lot of time. Now, you've probably seen how people have benchmarked LLMs against things like medical exams and legal exams, and so I thought it'd be really interesting to benchmark an LLM against network certification exams. And so in Juniper, we have a certification track where you've got 3 levels of multi-choice exam that you do on a computer, and finally there's a lab exam. And so I took the Fable 5 LLM, which has been in the news a lot recently, of course, and I started off with the associate level exam, which is the easiest. And on that exam, it scored 97.5%, bearing in mind that the pass mark is 70%. And so, encouraged by that, I thought I'd try it on a harder exam, which is the specialist exam. And on that exam, it did even better. It scored 100%. And then I thought, well, let's try it on the professional level exam. And that professional level exam is quite tough. It's not just rote learning. It's more like problem solving, solving networking puzzles. And even on that, it scored 97.5%. So they're getting very, very good in terms of networking knowledge. Bearing in mind that this LLM is not specific to networking. It's just been trained on the general content of the internet, but in so doing, it will have been exposed to things like discussion forums, blogs, vendor tech pubs, and so on. And so it's picked up that knowledge along the way, alongside pictures of cats and how to repair a washing machine and things like that. Now, I thought it'd be interesting to look at this benchmarking in another dimension. So looking at that hardest exam that I tried, the professional level exam, how have LLMs progressed over the generations, over the course of time, in that hardest exam that I looked at? And here's the results of that. And so if you look at Opus 4.5, which was released last November, I mean, that's only 6 months ago, but now it seems like a very old LLM. That scored 77.5%. And then the next one along, the green column shows Opus 4.6, released in February, and that did better. It scored 80%. Opus 4.7, released in April, scored 92.5%. As you saw on the previous slide, Fable 5 got 97.5%. So it's an increase of 20 percentage points in just 6 months. That shows the rate of progress. And in fact, it was around the Opus 4.5 generation that I saw, these are getting really good. They're actually doing useful work for you. That was a sort of breakthrough points in the LLM progression. Here's an example question from that exam, the hardest of the ones I looked at. And as you see, it's not just a simple question and a fact that you answer with. The LLM has to read the question at the top of the slide, it has to read the text, it has to understand that network diagram, it has to understand those config snippets and put it all together, come up with an answer, and it does it in a few seconds flat, faster than a person could. And so now let's see how we can actually make use of this. How do we actually leverage this type of LLM for networking tasks? And yesterday you heard about MCP servers, very useful technology for this. So an MCP server exposes functions or tools to an MCP client, which is in turn connected to an LLM. And so the LLM can call these functions to extract information from underlying systems. And so, for example, you've got the Junos MCP server, Junos being the operating system that runs on our routers. There's an open source MCP server. You can simply download it from GitHub, and that exposes functions to the LLM, such as allowing the LLM to issue config commands to the routers, issue show commands to the routers, apply a config to the router, exchanging it for the existing config, things like that. And then, typically different types of domain in the networking space. They'll have various controllers and so on, and there'll be MCP servers associated with those. And so you can take your laptop and put the MCP service on your laptop, have an MCP client such as Claude Desktop or GitHub Copilot, connect it to an external LLM, and you're ready to go. So it's very easy to make use of LLMs in this way. For the examples that I'm going to show you in a few minutes, this is the setup that I had. So I had my laptop. I chose to use Claude Desktop, and I was using the Claude Pro license tier. So that's the cheapest paid-for license. So that's the one that costs £18 a month flat rate. So you're not paying any extra, on a per-token basis. It's a completely flat rate plan. And in the case of the first example that I'm going to show you, I was using the Sonnet 4.5 LLM. And in the second example, Opus 4.6, I had the Junos MCP server on the laptop, and that connects via netconf over SSH to the routers in the lab setup. Now, very interestingly, I didn't supply any supplementary information at all to this setup. I didn't supply any documents, I didn't supply any network diagrams, I didn't supply any so-called skills where you can describe how to do a particular task, none of that, because I wanted to show what's possible, with just the bare bones config, as you can see here. And so here's the first example. This is related to network emergencies, network outages. And a few years ago, there was a major outage on a global network in which all of the traffic just stopped. There was no traffic flowing across the network at all. All the protocols were down. And it took between 1 and 2 hours to, for people to work out what was going on and get the network going again. And so what I was interested in doing was seeing if an LLM presented with this situation could actually get to the root cause faster. And so what I did is I built a sort of replica of the setup in the lab, routers with the same condition present to see what the AI could do and what it could find out. And so here I'm going to show you a video of how it progressed with this. And so you can see my prompt here. This is what I type into the chat window of the desktop client, which, as I said, was Claude Desktop in my case. And this is just a very sort of basic prompt. I just said all the protocols are down on all routers, work out the cause, no more detail whatsoever. I'll run a video. This is running at about 2 times speed, just so people don't get bored, but it all happens pretty fast. And so what happens is, first of all, the LLM says to itself, okay, let me check BGP. I see BGP is in the active state, which is bad. It should be established. OSPF has no neighbors. That's bad. The interfaces are up. Let me see if there's a control plane filter blocking protocol packets to the routing engine. And it finds that there's a firewall filter with multiple terms. And the second term of that firewall filter has no matching from term. It just says then reject. And so it's rejecting all packets that hit that filter. And terms subsequent to that were the ones that would have allowed things like BGP and OSPF through, but they never get to see that term. Furthermore, the LLM, from the name of that bad term, which is no source route, that was the name of it, infers that the original intention of that term was to block packets with source routing. And so it suggests a fix. It says, do you want me to add the from phrase to that filter to fix it? I say yes. And so it applies that to the routers. A couple of minutes later, everything is up and running and working fine. So that filter was exactly what happened in that real incident, but as I said, it took between 1 and 2 hours for people to actually work out that that was the problem. And so in that video, well, actually in real time, it took the AI less than 1 minute to find the root cause and about 3 more minutes to apply the config and check that all the protocols were coming up and so on. Bear in mind that that chat that I showed you, that was a complete cold start. So when I typed in that prompt, all the protocols are down, the LLM had never looked at the network. It knew that it was connected to a Junos MCP server, but it doesn't look unless you give it a prompt that triggers it to want to look at the network. So it's a complete, cold start from scratch. So as such, it's equivalent to somebody joining your company and they walk through the door on the first day. You say, hello, welcome to the company. By the way, the network's down, please go and fix it. And so I think that this type of use case actually dealing with network emergencies is actually a very good one for LLMs because it's an extra pair of eyes in the room. You've got nothing to lose because the network's down anyway, and it might get to the root cause quicker than you. It might give you some clues to help you get to the root cause quicker than you would have otherwise, or it might just eliminate some blind alleys. So it's an extra pair of hands to help you along. Let's now have a look at the main thing that I'm going to talk about today. And the background behind this is evaluation of new capabilities that you might want to introduce to your network. And often the barrier behind that is the time taken to test and evaluate it in the lab, because just building a lab setup and creating the configurations can take a long time. In the case of the example that I'm going to show you, BGP Roles, there's a lot of prerequisites. You need several eBGP sessions, you need AS numbers configured on the routers, an IGP probably, and so just configuring that is quite tedious before you even get to try the new feature. But the LLMs are very capable of doing all of that and actually configuring and testing the new feature as well. And so we'll see how we can do that using RFC 9234 as an example, which is BGP Roles, in conjunction with the Junos MCP server. And so here's a reminder of how BGP Roles works. So if you imagine you're that ISP in the middle of the slides, routers R1, R2, R3, and you're peering with various other ASs, if you take router R3 as an example, on that eBGP session with provider 1, you declare your role as customer, and that's actually carried in the BGP open message. Provider 1, because they're the provider, on their side they declare themselves as the provider, and so the BGP session comes up because that's a compatible pairing. If, on the other hand, both of you had declared yourselves as customers, that's meaningless, that's illegal, and so the BGP session wouldn't even come up. Staying with router R3, when you're pairing with one of your customers, customer 2, you declare yourself as the provider, and they declare themselves as the customer. And then also there's another type which is shown, which is when you're pairing with lateral peers, and in that case, both of you on each side declare yourself as peer. And a key property of this RFC is that there's an only to customer attribute, OTC. And what happens is that a provider, when it's peering with you, would add that attribute when it's sending prefixes to you as the customer. And also peers also add that attribute as well. What that attribute ensures is that you, in turn, do not send that to other prefixes, to other peers or other providers. You only send it to your customers. On the other hand, prefixes that you receive from your customers go everywhere, as you would want them to. And so the overall goal of this RFC is preventing root leaks of this type without you having to configure specific BGP policies and add communities and so on in order to achieve it. It's something that we've supported since the middle of last year. We were the first commercial router vendor to introduce this. And so let's have a look at how I went about having the LLM help me set this up and test it in the lab. And so I started off with a very bare bones config. The topology is shown here. Just IP addresses on the links and the loopbacks, ISO addresses on the loopbacks, but no protocols configured, no AS numbers configured at all. So it's a very bare bones config. And so this is the first prompt that I give to the LLM. And in this one prompt, this is what I typed in, I'm actually asking for a lot of things. I'm asking it to configure ISIS in that central ISP. I'm asking it to configure an AS number on each router. I'm asking it to configure all of the eBGP sessions and also a full mesh of iBGP in that central AS between those routers in the middle, R1, R2, R3. So that's all one prompt. I type it in, hit return. I come back a few minutes later and it's all ready, up and running. And so this is some of the output of the LLM because it gives a running commentary as it goes. And that prompt that I showed you on the previous slide was a complete cold start. So it knew nothing about the network, didn't have a diagram. And so the first thing it needed to do it realized, was to work out the topology for the network. And so what it did is it asked the Junos MCP server for the configurations of all the routers. It looked at the configs, it looked at what subnets were configured on each of the interfaces, and so it matched them up to work out which interface on which router was connected to which interface on which other router. And so it summarized its findings in this table. So you can see a list of all the links in the network and which ports and which router were involved. And then it confirms that it's configured ISIS, and that's up and running. It said that in order to get it going, it needed to enable family ISO on the links between the routers, because that's a prerequisite for ISIS to come up, so it did all of that as well. It's given a list of AS numbers that it's configured. I said to use private AS numbers, but it wasn't specific, so it's proactively just assigned AS numbers off its own bat and assigned those to the different routers in the network. And then it's confirmed that it's configured the eBGP sessions, and they've all come up. And then finally, it confirms that it's configured the iBGP full mesh, and those have come up as well. And it's noted that it used the loopback addresses for those iBGP sessions. I didn't specifically ask it to, but it just knows from its training that it's common practice to use the loopback addresses for iBGP, and so that's what it did. And as such, my prompt was somewhat intent-based. As you see, I don't have to be very specific and spell out every single micro step. It works out all of the details on its own, which is part of the reason why it's so useful. You know, if I had to give a step-by-step breakdown of what to do, it would have been faster to do it myself, of course. And so now I need some routes to carry in BGP, and so I ask it to configure static routes and redistribute that into BGP and check that they propagate. And so it gives a list of the static routes that it's assigned and configured on each of those routers and the other ASs. It's described at the bottom of the slide you know, what it had to do in order to achieve that, like creating policies to redistribute into BGP, and then applying it on those eBGP sessions. And then also it notes that in order to get the prefixes to propagate through that central AS, it needed to turn on next hop self on the BGP sessions, on those iBGP sessions, otherwise the prefixes would have been unusable, so it just sorted that all out proactively as well. And so at the end of the day, it confirms that all of the routers can see all of the prefixes in the network. And so in just a few minutes, I was ready to actually have it configure the thing of interest, which is the BGP roles. And so this prompt, I just say, configure on the BGP sessions appropriate roles as discussed in RFC 9234. And I don't give it any more details about how to go about it. I'm just hoping at this stage that it will know what to do, which in fact it did, as you'll see in the subsequent slides. Very interestingly, the training cutoff date for this LLM was before the date that we actually introduced the feature on our routers and published the corresponding configurational guide. So during its training, it won't have seen how to do the config on our routers. But that's fine, because behind the scenes, the LLM just does a web search, finds out the information, consolidates it with information it knows from its training, so it would have been exposed to the RFC itself during its training, and so it crunches through the work and does it all. And so here's the outcome report from the LLM. So from the names of the routers, it just worked out the roles. Because I had useful names like customer 1 for one of those routers, it worked out, well, that's obviously a customer then, so it gave it the role of customer. And so on our side, R2, it gave the role of provider. You've got the opposite at the bottom of the table, where our router, R3 and R1, are customer in the context of their sessions with provider routers, provider 1 and provider 2 respectively. And then in the middle of the table you can see the roles of peer that it configured on those sessions with lateral peers. Here you can see an example config snippet. The items in black font it had done in previous rounds, in the earlier prompts that I showed you, and the highlighted yellow ones are the ones it added for this BGP role. This is an example from R1. And so then everything's been configured. So I just say, okay, look at the roles that you've configured on the eBGP sessions on each router. Look at what prefixes are received by each router and see if that's compatible with what you'd expect given the way the RFC works. And so it gives a summary. It says, well, the customer routers received all of the prefixes. The peer routers only received 2 prefixes, as did the providers. And that's because the peers and providers only received the customer prefixes as per the RFC. So there were 2 customer prefixes in total, and that's what they saw, while the customer routers see everything as you'd expect from the RFC. And so it concludes that everything is working as expected. And so the final prompt I give is write a blog about how this RFC works based on the network, for an audience who understands networking, who understands BGP, but might not be familiar with this particular RFC. And so in 3 minutes flat, it writes a blog in HTML format, which is very, very good quality. I'm going to show you a quick scroll through this blog. One of the links at the end of the talk allows you to see this whole blog in full. But even the abstract is great because it says a walkthrough of the RFC's role-based route leak prevention, showing exactly which prefixes propagate and which don't, which is the whole essence of the RFC. So it captured it very well in that short abstract. And then if we run this video, this is a real quick scroll through. It talks about the problem statement, route leaks, how the RFC solves it. It talks about the lab network. It proactively color-coded the different types of prefixes. So customers are green, purple for providers, orange for peers. It talks about which prefixes each type of speaker received. And then it gives a summary table where you can see that the customers receive everything, while the peers and providers only receive those green customer prefixes. Then it talks about the Junos config, how you configure this in Junos, and then a summary at the end. So that was a really good blog. This is an example of a type of documentation, but of course you can also use it to create internal documentation that you use in your network operations. You could ask it to write a configurational guide explaining how this RFC works in the context of your network and how you configure it. A colleague of mine is working with a major service provider on having an LLM write MOPs. And so what they did was to feed the LLM examples of MOPs that had been written in the past by that service provider with annotations about what sections are mandatory for all MOPs and which ones are optional depending on the type of MOP that it is. And then it wrote a really good 60-page MOP for a new migration that they had to do, and it saved a lot of time compared to doing it manually. And writing MOPs is quite a bit of drudgery, as you may have experienced. So having an LLM do the hard work is actually very helpful. Now, some commentary on this testing of the RFC. As you saw, the LLM could handle quite complicated multi-step prompts. That first prompt I gave it was asking for a lot of work, and it did it all in one shot. In fact, all of the lab work took only 16 minutes, which was much, much faster than it would have taken me to do manually, and more accurate as well. And as you saw, it took the initiative to check things without being explicitly told. It checked that ISIS came up, checked that BGP came up, it did fixes proactively to make sure they indeed came up, and it wrote a very good quality blog afterwards. Now, here's an alternative approach, because the approach that I just showed you was a sort of on-the-fly approach where I said, do this, do that, and progressed in that way. A more structured approach, which is better if you want to reuse the work in the future, if you want to extend it in the future, is to, first of all, ask it to create a document, which is a plan of how it's going to configure and test that feature. This is the only prompt I gave for it to do that. And you'll notice that this prompt is actually vaguer than what I showed you before, because here I just allude to prerequisites, but I'm not spelling out what they are. I'm not saying you must configure the AS numbers, you have to configure iBGP sessions, you must configure eBGP sessions, etc. I'm just saying, I want you to build something on this network to test the RFC and make sure you deal with the prerequisites. And so, as such, this is much more intent-based than the previous sort of line of prompting that I showed you. And it came up with a very, very good document. Here is just an excerpt from it, where it actually highlights the prerequisites. And so it's saying, well, autonomous system hasn't been configured, so those need to be added. Please see section 5.1, where that's discussed in more detail. You need an IGP in that middle network, that's not configured, see section 5.2, IGP full mesh, eBGP sessions, etc. And then finally, configuring the roles themselves. And also, it's decided to build the network in phases. So I didn't tell it to do this, but it decided that phase 1 would be configuring the IGP and making sure that all works, the loopbacks are reachable within that central network. And then BGP without the roles configured to act as a baseline, and it called it the deliberately leaky baseline, so everyone sees all of the prefixes. And then phase 3 is to add the roles and then check who sees what. And then also, the phase 4 is very interesting because it's proactively suggesting negative testing, like having deliberate role mismatches, illegal combinations of roles to make sure that those don't come up. So that was a really good suggestion from the LLM as well. So as you can see, they're very useful and they can help you save a lot of time and do a lot of useful tasks for you. Finally, some references. The RFC itself, the Junos MCP server, that's open source. You can just download it, put it on your laptop, use something like GitHub Copilot or Claude Desktop, and you can be up and running very quickly. Finally, an article about this testing with some more detailed screenshots and so on, and that complete blog that it wrote to describe the work it had done. So with that, thank you very much.
Hi, Simon Lockhart from Bogons. I think this is fascinating because I've been spending a lot of time using AI for software development, and it made me think about some of the challenges I've had, that when you asked the LLM to work on your network, you'd already pre-configured a chunk of it. It already had loopback addresses and things like that. The problem I tend to find is that it makes assumptions. It doesn't ask you if it's not sure. And so you sort of, it felt like you gave it a nice clean environment to work in where it already knew everything, rather than, oh, there's no loopback addresses configured. What addresses should I use for that? Maybe I need to go and look in Netbox or something else to get those. So how does that sort of fit into this?
Right. Yeah, I mean, I could have given it an even more bare bones network. I could have missed out the IP addresses and it could have done those. I mean, I just started off, I had a script anyway that creates that bare bones network, and so that's what I used as a starting point. One thing is, one thing is striking a balance between how much you put into one prompt rather than separating it into multiple prompts. Because if you try to put too much into one mega prompt, which might have 15 different things, they can get lost somewhere in the way and sort of grind to a halt. And so I prefer to be a bit more cautious and err on the side of having slightly too many prompts rather than too few, because grinding to the halt is a sort of annoying thing. In practice, documentation is a good way of achieving it. So that second way of doing it, where I asked it to write a test plan, first of all, well, actually a test and configurational plan, that's a good way to do it, because then it's sort of almost encouraging it to create some structure in the way it goes about things. And then you've got a concrete thing to look at before it executes. So, for a more complicated task, maybe it will create a document, but there'll be a couple of things where you think, it ought to be done slightly differently. And then you can ask for amendments. And then once you're happy, you can proceed to the next step. It's almost like having a junior colleague, actually. So some of those things that I did, I was saying to a junior colleague, okay, I want you to test these roles, but first you're going to have to configure the AS numbers, you're going to have to configure the iBGP sessions, the eBGP sessions, etc. But I didn't have to spell out step by step, because I know that that colleague would know, that you do use loopbacks for pairing with the IGP. So it's a bit like that with the LLMs, actually. So certainly, the more complicated the task, the more useful documentation is, and that also applies to the sort of coding example that you mentioned at the beginning of your question. I understand that people find that having documentation as the sort of first step actually helps with those sorts of tasks as well. And it makes it more extensible, because then if you expect just creating the document is going to be enough to sort of exhaust the LLM for the current context window, you can ask as part of the prompt, which is what I did actually, make the document something that's understandable as a self-contained thing for a subsequent chat, which is a called start, and then you could come back. It could even be a different LLM or just the same LLM the next day. You say, oh, here's a document describing how to do this configurational task, now go and execute it, which is in fact what I did. I mean, I forgot to mention, I took that document, I fed it to the LLM in a separate chat, and it actually crunched through the document and actually executed it onto the network. So yeah, that's a good approach.
I find that doing software development is useful the same. Is like you sort of have a conversation with the LLM and you sort of, right, that was good, that was bad, do that this way. Now spit out a document into the repository so that you can refer to it without me having to explain all that again.
Exactly. And then the other thing is, you can have documents which you can have as a sort of local reference folder that the LLM can refer to, which could be, configurational practices, so you don't have to repeat them in every prompt, in every chat session that you do. You could, have it look at the configurational practices document as a sort of prerequisite for its task that you've asked it to do. As I mentioned, I didn't do any of that because I wanted to show what's possible with just completely bare bones setup, but in sort of real life scenarios, I imagine that people would have, a few documents in a repository in terms of, sort of practices that you use in your organization that the LLM wouldn't know about otherwise, that sort of thing.
Yeah, that's great, thanks.
Hi, David Groves from Nominet here. I did something very similar a couple of months ago where we were trying to figure a way to train like engineers who know about DNS but don't know about networks with a fake worldwide network with a couple of backbone providers and some providers that appear in weird places. And I basically got it to write a plan where, again, I told it some of the most basic stuff I wanted, like I wanted a BGP core with a couple of route reflectors in 3 ASNs, but I just had it completely build it from nothing with on local container labs, FR routing, and I was very impressed. It took me about 2 days of work to get it fully up and running, and it had a lot of intuitions that I didn't expect it to have, and it's also got some advantages, like I got it to build a JavaScript program that draws maps of the networks and stuff like I just could never do that. So I was kind of terrified by how good it was. Yes.
Yeah, same here actually. I mean, it would have taken me longer to do it manually, and I think I would have made mistakes because the thing is, like, for example, this config is each eBGP session is different because the AS number on each end is different. Now, what I would have done is configured one eBGP session, and then I would have copied it, edited it, and pasted it, but I probably would have messed up one of the AS numbers in so doing, and one of the sessions wouldn't have come up or something, and would have had to go back and fix it. So I think the accuracy now is better than, a person doing it themselves often. Although they can make mistakes, LLMs still can make mistakes. They, can hallucinate. Sometimes. So I guess we still have to be careful. It's like having a rather competent colleague, but, perhaps they can make mistakes sometimes. So still, verification steps are still important. We can't expect to be able to skip those at the moment. Verifying documents that it's written or the actual work it's done.
Yeah, I wouldn't have trusted it on a real network, but on the laptop it was great. And there were a couple of real surprises. One of which was, I said, I built this international network. I can trace route across it, but the latencies are obviously not realistic. So I just said, hey, can you figure out how to use Linux TC to put simulated latencies on these virtual links that you've created? And it just did it.
Wow. That's really good. That's really, really good, yeah.
Greg Choules, ISC at the moment anyway. I think you've just made my job redundant, so it looks like I'm going to retire soon. I have one question for you, though. What's the carbon footprint of what you've done?
Right. Yeah, it's interesting, actually. Yeah, how many tokens have been burnt, etc.
No, never mind tokens. I mean, actually, how much CO2 has this put into the atmosphere?
Yeah, because
sorry
of
to
the
end the whole thing
GPUs
on a bit of
and
a downer, but
yeah. It's an I mean, it's a very good question, of course. I mean, definitely a good question. I suppose.
I'll leave you with the thought.
Yeah, it's a very good thought. I mean, I suppose, well, I mean, compared to a person, how much CO2 does a person use? But I suppose if the LLMs and the people are still there, it's a really good question. I mean, I take your point about the CO2, certainly.
Roll Golding, Studium. You mentioned that you hadn't trained this, you hadn't fed this the manuals, you hadn't given this your best practices, you've not given this the network diagrams. So essentially what this has done is found a couple of examples on Stack Exchange and a post on Reddit. What's the plan for the next generation? If all the engineers in this room are going to use an LLM to configure it, so they don't really know themselves, and therefore can't train the next generation, is there going to be anybody left who buys Juniper boxes if they don't know what they do and how to configure them?
Sorry, I didn't hear the last sentence.
Is there going to be, eventually, anybody who wants to buy a Juniper box if no one genuinely knows what they do or how to configure them?
Yeah, yeah. Right. I mean, it'll be interesting how it pans out. I suppose it's... Okay, so I suppose one sort of view is that configuration of routers is something that people have less direct involvement with on a day-to-day basis, and as such, it's almost a bit like assembler or machine code. I don't know how many people, do assembler or machine code on a day-to-day basis. Probably not much, because there's higher-level languages that deal with it, and so, machine code would be alien to a lot of people, and so one view is that router configurations like machine code, it's still there, but people don't have, sort of direct involvement in it very often. Or another example might be, I don't know if people remember, spinning hard disks and you had to do defrag on them. It used to be a sort of chore, like, oh yeah, I've got to defrag my hard disk, but it's not something that you think about now because it's all handled, automatically. So, it could be a bit like that, and then people are moving on to, sort of higher level tasks. I mean, I know in a lot of operators, say ones that do business services, one thing they don't like doing is what they call so-called specials. Like they might have a big business customer and they might want some, VPN services, but they want some, sort of strange routing. They might want you to send, I don't know, certain meds to certain sites according to some, various criteria. And that doesn't fit in with the way you normally offer this service, but it makes it more tenable to do the customization if you can have AIs, helping with the sort of configuration and associated documentation and everything. So, that's a sort of opportunity from it. I mean, this is the sort of more optimistic view. I mean, another analogy is in the early days of computer, people had to feed in punched cards into the computer. That was the program, and so some people's jobs was the person who actually fed the punch cards into the machine. Now, that particular job doesn't exist anymore, but that's not saying that the number of people employed in the, in jobs that involve computers has decreased as a consequence, because they've moved on to other types of tasks.